to do it. I can't find mine.
Remember I said that day after long weekends, the homework counts double.
I did it, but I can't find it.
Hey, that does remind me, this class, we had a number of people that, I mean, we kind of like homework is, for most of you, you're doing it fine, but there's just too many of you. When I reach, more than like 2 or 3 kids, we start seeing some homework drop off. Let's not have a homework drop, especially what we're doing right now. This is not the time to yeah, I didn't do my homework, right? We're in the meat of the hard stuff today. You got to do your homework. You got to have that practice. Any questions on the homework? Yes. Let's take a look at number 14. Number 14. Did I share this? Yes, I did. Number 14. What is it, Jonathan?
Sure.
Oh, why am I pulling the book out? It's worksheet. All right, number 14. Which was the last one? Okay, ugly, ugly, ugly fractions. When you deal with fractions and an equation, what must you get? Common denominators. When you're dealing with fractions and you have mixed numbers, what did I always tell you to do? Turn them into improper fractions. So as an improper fraction, number 14 would be -7/2 minus, so let me check my work here, 5/3v is equal to -1/2. Is that right?
Yeah.
Okay. Common denominator is?
2.
It's not 2. 6. So multiply top and bottom by 3. So we get what? -21/6. Got to multiply top and bottom by 2 minus 10/6v is equal to multiply top and bottom by 3, -3/6. Okay? All right. Get rid of addition and subtraction first. So I'm getting rid of this. -21/6. How do you get rid of that? Add 21/6 to both sides. I'm running out of space here. So once you do that addition, -10/6v. If I add 21 to -3, that gives me.
22/6.
If I add 21 to -3, I would get 18/6, which is just the plain old number. 18 divided by 6 is 3. Yeah? Jace, how do I get rid of -10/6?
You gotta multiply.
Both sides by?
-6/10.
Multiplied by the reciprocal. Multiplied by parentheses, -6/10. Nothing cross cancels there, so it's just an ugly number. What we get, -18/10, which will reduce to 9/5. 18/2, -9/5. All right, you got that one wrong. All right, of them all, right, this one computationally wise is very challenging. Of them all, I mean, the procedures, the steps aren't any different than the previous ones. And by steps, I mean, hey, to get rid of subtraction, we add. To get rid of multiplication, we divide. Right? But the actual steps are easy, but the computation is clearly hard because it's fractions. Yes?
I wasn't here for that, so I didn't know how to do it.
Okay. Well, I'm just going to say we're going to treat it the same way as we treat any 2-step equations, except it has fractions. All right. Anyone else? Who thinks they got them all right? Well, I just gave you the last one. What? 13. Let's take a look at number 13. Number 13, once again, deals with fractions. So we got 17/5, and I wrote 15. 17/5 is equal to 2/3x plus 3. Common denominators. I wrote it 3/1. Common denominator is 5, 3, and 1. Common denominator 15. So got to multiply the top by 3. That's what, 51? 51/15 is equal to, multiply top and bottom by 5. 10/15x, multiply top and bottom by 15 plus 45/15. Ugh. How do we get rid of addition? I'm going to subtract 45 from both sides. 51 minus 45 is 6. So we get 6 over 15 is equal to,
3/5.
I'm not going to reduce because you see 15, 15, and hopefully they're going to cancel. We'll see. 10 over, you could. What are we going to multiply both sides by? How do we get rid of the 10 over 15? So therefore we're going to multiply by, he said divide, and I said therefore multiply because I'm doing a copy dot flip. So then we're going to multiply both sides by 15 over 10, right? Because that would cancel, and this is why I held off on changing that, because you see the 15s, right? So cancel, reduce. 6 over 10 would be what, 3 over 5? So x is equal to 3/5. All right. You can do that one.
These are it's like just into common denominator.
You can't do subtraction.
It actually makes it easier.
Yeah, but how do you subtract 40? How do you subtract 3 from 17 over 5?
Oh, I do that.
Well, what's the answer?
It's 15 over 5 minus.
It's not 17 over 5.
No, you're subtracting 15 over 5.
Oh, so you still got common denominators.
Yeah, but I can do it in my head. So
All right, be careful with that because you can cause you problems.
if you just left the 2 and the 3, it cancels out.
Okay, I understand what he's saying. He's saying what he did was, instead of getting common denominators of all 3, he got common denominators only when he was required to, which was that subtraction. Because you don't need to get common denominators when you do multiplication division. All right, and then that would work as well too. Just be careful. Yes. At the end of class. All right. Well, I did hand it back to a few people. All right. A few people already got their test.
This is easy.
How do you even know if you got it right?
Because there's a okay, so
Let's not focus on high school geometry.
it's just the same. It's easy.
All right.
Yeah, you're gonna say that when you get to geometry.
Yeah, I'll remember that. All right.
You should call it that.
At least that part.
Collect. Collect.
I'll collect, yeah.
Pass out.
Give your homework.
All right, everyone else, your homework tonight will be another worksheet.
We get it right
No, because this is new stuff.
now.
All right, everybody look at the calendar. Let's see, we got a quiz at the end of the week. We'll start talking about it closer towards Friday. Here is your homework for tonight. Right? So remember, the homework's already on the board right now for the entire week. Landon.
That's all I heard.
I know. That's what happens when you're not listening. She said, I won't be here on Friday, so I said, yes, I put the entire week's homework already on the board. Those pieces of paper over there? All right, hey, no joke. From today through the rest of the chapter, it's challenging. Okay, really challenging. Like today is a big step up from last year. Last year we only saw two-step equations like very briefly. Today's not only two-step equations, it's the hard two-step equations that I need to show you. No, it's not because it has fractions or you're just different. And then tomorrow we jump into multiple step equations, right? The keys to staying, I don't know, or performing well, right, is this. You stay in the fight. That means every second in class you're paying attention, unless I say, okay, guys, work on your own, right? Then you're paying attention to your own work. But I'm saying you got to hang on to my words. You got to understand the procedures. It's just procedures, right? If you don't understand those procedures, you can ask questions. You don't wait to the end of the class like, I didn't get any of that. Ask questions during the moment, okay? Obviously, I offer tutoring any day of the week except for Friday. If you need to come to tutoring, please just tell me that. But let's fix this before we get to quiz day or test day. If you need extra work, I know nobody wants to do extra homework, but I'm saying it's a possibility, right? You get better by doing the work. What I would highly recommend for many of you, maybe not a two-step equation, but we get the more challenging ones, like put an example on your resource card. Hey, I struggle with the ones when there's variables on both sides and there's distributed property. Then have that example of one like that with notes of how you, what's your first step, your second step. Have that on your resource card. Take the practice test and pull it off and put it on your resource card. Right? Don't forget the basics. If there's a mistake to be made, it's generally adding or subtracting, not multiplying or dividing. Although multiplying and dividing, people will drop a negative. When we write test questions as math teachers, we like nice friendly answers like 4 and 1, right? Negative 17 over 31, even though occasionally that is an answer, is not a friendly one. Rest assured that if I write a test, right, I want to make my life easy too when I'm grading it, so I'm not going to have crazy answers. The problem with solving algebra problems, if you do the first step wrong, it throws everything way out of whack. So you do get these crazy answers of 257 over 143. Well, that's what happens when you do one step incorrectly with adding, subtracting, or multiplying or dividing with a positive or negative. Clearly, multiplying and dividing fractions, we still need some work on it, since those were the questions from last night or over the weekend's homework. So we will continue. You'll see a couple of them today as well, too. But please stay in the fight. All right. So primarily, it's the special case 2 steps ones that we'll look at today. So box 1, who can do it right now? Box 1.
I can.
Then do it. For the rest of you, let me walk you through it. So we know it's a 2-step because when I look at the equation and I decide what side is the variable, remember equal sign breaks it in half. I look at the left side because that's where the variable, in this case, p is. There's 2 numbers there. There's a 2 and a 5. I need to get rid of the 2 and the 5. So you have a choice. You can get rid of either one of them first, but there's the easy way and the hard way. 99.9% of the time, except for today, right? We're going to get rid of addition and subtraction first. This is an easy one, not a special case one. So we're going to get rid of addition and subtraction first. Hey, let's get rid of the 2. How is the 2 attached to the letter P? How do you get rid of subtraction? So what are we going to add to both sides? We're going to add 2. Not the number we're trying to, I don't know, 18, I don't care about it. I care about the number trying to get rid of 2. To get rid of minus 2, we add 2 to both sides. 2 minus 2 is 0. Poop, it went away. But 18 plus 2 is 20. I got rid of 2. Now we get rid of the 5. The 5 is attached to P by, we get rid of multiplication by, we divide both sides by the number we're trying to get rid of, not 20. Trying to get rid of 5. 5 divided by 5 cancels. Technically, it turns into 1. 1 times P is P, so P equals 4. Yes? Sure. Those are the easy ones, right? We're going into much challenging ones today and tomorrow and the next day. Today's the last day you'll see 2 steps, but we'll, I should say, the last day we will only do 2 steps. We will move on to multiple steps tomorrow. Some of you think this makes it harder. It doesn't. The logic or the steps behind it is no different. Granted, the calculations are a bit more challenging, but the steps are still the same. Notice variables on the left side again. I need to get rid of 0.5 and 1.2. Jenna, which is the first one I'm going to get rid of? Which one? Let's get rid of 1.2. 1.2 is attached to x by subtraction. To get rid of subtraction, we do addition. So we add 1.2 to both sides. Do you remember doing this one on Friday, Jenna? Okay, it was the same one. All right, 4.8, 1.2. Remember, for addition and subtraction, you line up the decimal places. 8 plus 2 is 10. 4 plus 1 is 4. Plus 1 is 5. Why did I say that? 4 plus 1 is 5. Plus 1 is 6. I have no idea what I was thinking there. All right. 0.5 is attached to x by multiplication. We get rid of multiplication by division. Okay, so this one's going to require some scratch work. Off to the side. Occasionally I get 8th graders that still put the wrong number inside the long division symbol. You've heard me, for those who had them, I think of this as a tree. When you cut the tree down, the tree falls to the right. So what falls to the inside would be the top. In other words, the 6. I'm not going to show you the long division, but 6 divided by 0.5 when you do the math is 12. Okay? Granted, it has decimals in it. Yes, it makes the calculation more unfriendly, but the procedure doesn't change. Questions on solving a simple 2-step equation. Moving on. Now we get in the world of fractions. Now it becomes slightly more challenging. It's still the same procedures. Abby, what side is the variable on, left or right? I'm looking at the left. What numbers do I want to get rid of? And which one you want to get rid of? We're going to get rid of minus 13 by adding 13 to both sides. So we add 13 to both sides. 2 plus 13 is 15. Box 3, people. Abby, what number now? How is 2 attached to B? How do we get rid of division? Now, just be careful when you write that. You're not going to put the 2 next to the 2. That 2 times 2 is 4. It doesn't get rid of anything. So we multiply both sides by the number 2. On the left side, I wrote as a fraction because we get rid of fractions by multiplying by other fractions. 2 divided by 2 cancels. Technically, it turns into 1. That red line there means the number 1. 1 times B is B. 15 times 2 is 30. Yes? That's where we left off. Today, we get the so-called special case ones. Here's one, okay? All right, here we go again. Lucia, which one are we going to get rid of first? Or what 2 numbers do I need to get rid of?
Negative 6 and wait.
And
2/3.
which one you want to get rid of?
Negative 6.
Nobody wants to mess with fractions, right? Absolutely. Let's get rid of this negative 6 first. We do that by
Added.
both sides. Okay? 14 6 is 20. Now we get rid of 2/3. How is 2/3 attached to n?
Wait,
How is this number attached to n?
multiplication.
How do we get rid of multiplication? Last chapter we divided fractions. What do we always say when we divide fractions? Copy dot flip. So the only question is, what am I flipping? Here's how you remember this. The number, when it's a fraction attached to the variable, is the number you're going to flip. As soon as this number on the right side is a fraction, I'll see kids flip this fraction. The one that you flip is the one that's attached to the variable. So what am I going to multiply both sides by? You just take the fraction, you flip it. So what am I going to multiply both sides by?
Can't say it. 3.
You can literally say the words 3 over 2. So I multiply both sides by 3 halves, 3 over 2. Okay. Why do we flip that one and not this one? Because I'm trying to get rid of the red 2/3. 3 divided by 3 is 1. 2 divided by 2. That's why it cancels. If we were to multiply both sides by 20 over 1 or 1 over 20, it would not get rid of the red number. The red number is the one we're trying to get rid of. The key here is to remember. Now, usually, I should put a better example where the 20 is a fraction too. I'm trying to get rid of this red number. So always multiply by the reciprocal, fancy word for flipped, right? By the fraction that's attached to the variable flipped. Who's lost? Okay, what part? Okay, when you have a fraction attached to a variable, take the fraction and flip it. So what am I going to write? And that's what you multiply both sides by. Both sides. Well, therefore, that needs to be a fraction as well, too. Okay. 20 times 3 is 60. 60 divided by 2 is 30. Or you could do some cross canceling. 2 goes into 2 once. 2 goes into 20 10 times. 10 times 3 is 30. Either one. Notice how fast I'm talking, right? You're in 8th grade now. You've done this a few times, right? If I'm talking too fast for you, it's your job to slow me down. Okay? All right, questions. All right, enough of a review. Here come the special case ones. I would argue the last one is a special case. Here come the special case ones. We're only going to do a few of these, and that's it. For those of you that have great resource card, these are probably the ones that you want to have on your resource card because they're special case ones. Here comes the first. Oh, this isn't the first one. We just did this one. You get rid of the minus 13 by adding 13 to both sides. Notice the difference between the two. Both have variables on which side?
Left.
So looking at the left side, both have two numbers to get rid of. Minus 13 and a 2. Plus 4 and a 3. They both have two numbers. Both of these are two-step equations. We know how to do the one on the left. Add 13 to both sides, then multiply both sides by 2. This is the one that will kick your butt. So visually, what's the difference? Visually. What do you got?
The 4 is in the fraction. That's plus 4.
Okay, there's a plus 4 and it's part of a fraction. What else do you see visually? Like, how do you tell the difference between this one and this one? Because we know how to solve this one. I'm claiming this one's done differently. It's a special case one. Jaden, visually, what's the difference?
Visually,
Visually.
they're doing plus 4 to minus 13.
Okay, agreed. What do you got, Gabby?
The variable, you add like the variable with another number, but they're both being divided.
Notice on the one on the left, it's just b in the numerator all by itself. Gabby said the one on the right, well, there's the variable in the numerator, but also you're adding something. We also could be subtracting something as well, too. Notice how many terms are in the numerator here. How many terms are in the numerator here? That's how you visually identify this one. The one that's different, the one that we get new rules for, is the one on the right. For me, it's got a long fraction bar. Visually, hey, the fraction bar is really long, right? Gabby said it a bit more mathematically. We got more things going on in the numerator here, too. And over here, we only have one thing in the numerator, 1. All right, who didn't follow that logic of what's the difference? Do you see a long fraction bar?
Yes.
Do you see a short fraction bar?
Yes.
Okay, there's their difference. Okay, for the ones with the long fraction bar, I'm going to blow your mind here. Guess what that number is?
4.
It ain't a 4.
Plus
Positive 4.
It ain't a positive 4 either.
Negative 4x.
It ain't a negative 4.
Oh, it's 4 over 3.
It's 4/3.
What?
That's not a 4. It's 4 over 3. It's 4/3. Over here, what was our first step? Our first step here was add 13. Yes, everybody see that? If you wanted to get rid of that number, guess what your first step is?
4/3 plus
Who wants to subtract 4/3 from both sides? Not me, right? So this is the only time. The only reason we got rid of addition and subtraction first because it was the easiest. It wasn't because it was the wrong way or the right way. It was just the easiest way. For this one and this one only, we're going to get rid of the division first. So when I tell you this, I don't want you to get rid of division first here. I want you to get rid of addition and subtraction first. On the ones with the long fraction bar, I want you to get rid of the division first because it's easiest. If you want to get rid of the plus 4, you actually got to subtract 4/3 from both sides. Ugly. So how about we do it the easy way? Okay. So box 4, let's do it together. Box 4, let's do it together. Box 4, let's do it together. Okay. All right, here we go. Am I going to get rid of the 4 or the 3 first?
3.
How is the 3 attached to the variable? How do we get rid of division? So we're going to multiply both sides by 3. So we're going to multiply the top by 3, and or I should say the left by 3, and the right side. Why did I write 3 over 1 on that side? It's already a fraction, okay? Now, appropriately, with a multiplication symbol, there should be parentheses right there. You don't have to put parentheses. Okay? But this says 3 divided by 3. What's 3 divided by 3? And the 3 cancels. This is why, for this case, in this case only, we get rid of division first. 12 times 3 is? It's pretty simple. But you have to visually identify what's one of those special case ones. Therefore, we get x equals
30.
next year. This step right here, most of you will skip. You do enough of these, all of a sudden you start saying, well, yeah, obviously the answer is x equals, because seems like a kind of useless step here, because you know how the story always ends. This year I still want to see the step. Okay? All right. Remember, the only time I want you to get rid of your division first is when it looks like this. For some of you, it might be long fraction bar. For others of you, it might be when there are numerous things in the numerator, or more than one term in the numerator. Okay? This is the one you get rid of division first. This one we're going to get rid of addition first, or in this case, subtraction, right? Okay? Can you visually identify the two? All right.
Yeah.
Second special case one. You see it? Okay. Ideas? What do you got? We could. Any other ideas?
3 first.
He said 3 first. Oh, by the way, guess what that number is? It ain't a 1.
-1.
It's not even a -1.
-1.
Guess what this number actually is?
1 over 1.
Somebody said it.
-1/3.
No. This is actually -3 that I'm pointing to.
Yeah, 'cause
This is actually -3 because of the distributive property.
That's what I meant.
If we did the distributive property, right, that's actually not t, that's, and that's not a -1, that's,
-3.
so that's what the equation really is. So guess what I want you to do first?
-3.
I want you to do the distributive property first. And then it's a two-step equation, right?
Yeah.
Okay, now, some of you would argue that we could get rid of that 3 by division. We could. I want you to keep that in the back of your mind. I want you to do the distributive property first. And maybe not tomorrow, but the following day, I'll explain why we don't divide both sides by 3. We could, by the way. All right, what am I going to do first here? Add 3 to both sides. Now what?
3 by both sides.
And I'll give you guys a chance to catch up. So we get t equals. Okay. So when you see the distributive property, special case, do the distributive property first. Questions? You got it right now? Well, you wouldn't write underneath, that would be division. Thank you.
Number 7.
All right, we good? All right. This is actually a two-step equation, and this is usually I will see half the class get this one wrong. Looks pretty simple, right?
Yes.
You ready? All right. What number am I going to get rid of?
3.
3.
The students that aren't paying attention, guess how they get rid of it?
Addition.
Because they see this minus and they're like, well, I need to, well, the 3 is attached to the x by subtraction. It's not. It's a positive 3. So you don't get rid of a positive 3 by adding 3. If you added 3 to 3, you could get, instead of adding 3, we actually, for this one, right, the reason for that is this. Notice the order that I wrote it. Typically, we write x minus 3 equals 5, yes? Now what do we do to both sides? We add. If I make this 3 positive, and I make this one negative, and then move 3 to the other side, guess what it says now? 3 minus x equals 5. So technically, that is this equation. And if I write it like this, no one makes a mistake. How do you get rid of the 3 here? No one will make the mistake. But as soon as I put the 3 to the other side, then everyone wants to, they want to add 3 to both sides. 3 plus 3 is 6, by the way. You get 6 minus x equals, in this case, 8. Yes?
Could you just like do like this with minus x?
You could if you wanted to. I would not recommend it because it just seems like extra work. He was saying, could I just rewrite it first? Just deal with what you got. 5 minus 3 is, did we ever get rid of this minus x?
No.
Now we got a problem. Does it say x equals answered? It says minus x equals answered. How do we handle that?
With
No,
the negative number.
You add.
Two ways of doing it.
You add.
You add.
All right, two ways. One, the hard way. All three of you said the hard way. And then there's the easy way. I'll show you the easy way, then the hard way. What number is always in front of x?
1.
That number.
So what number do I really need to get rid of?
1.
That ain't a 1.
So what
One
plus
is
2.
That ain't a 1.
Negative 1.
So how do we get rid of negative 1? How is negative 1 attached to x?
Multiplication.
How do we get rid of multiplication? So what are we going to divide both sides by?
By
Negative 1. Okay?
And then that would equal negative
So therefore, x equals.
Negative 2.
All right, so there's the easy way. Now, here's the hard way. And it will still get you the same answer. You said you wanted to add x to both sides. Okay, that'll work. Let's add x to both sides. To both sides. What's x minus x?
Cancels.
Doesn't cancel. What's x minus x?
Oh, minus x.
0.
What's this say now?
2 plus x.
Ah. So now what do we need to get rid of?
2.
So how do you get rid of 2?
Subtract.
And that's why x equals negative 2. You think that's easier?
Yeah, that's way easier.
Okay, then do it that way.
I figured it out.
The rest of us will just multiply or divide everything by negative 1. Or a lot of students just realize this, is that because the answer is x equals negative 2, if you're presented with this, you just write the opposite of everything you see. The opposite of negative x is, the opposite of negative x is, and the opposite of 2 is, a lot of kids just say, well, I'm just going to flip-flop the signs. Yeah.
Yeah, that's exactly what I said. Just read the negative.
And mathematically, what you're technically doing is you're dividing both sides by negative 1. Some kids think of it as multiplying both sides by negative 1. Same idea. Whatever you do to one side, you can do the other side. So if instead, I just wanted to say, hey, let's multiply both sides by negative 1, I can. Negative times a negative is a positive. That's kind of how this turns into that. Please stop. Okay. Good? All right. This one is sort of kind of like it, but once again, I will get kids that will do what to the 14? They will add 14. If you remember, the signs are always on the left of the number. So when you're dealing with the addition subtraction step, look to the left of the number to decide whether it's positive or negative. That's a positive 14. So therefore, we need to subtract 14 from both sides. Okay, this is box 7. 22 minus 14 is positive 8. And then occasionally I will get students, they will even know what to do. Well, when they drop the 2 down, they forget that it was minus 2. They just drop the negative completely off. Okay? You could on this one, but that would be nice because they're all even. But what happens if that was 21, right? You get a fraction, right? So yes, you can remember whatever you do one side to the other side, you can do even the wrong thing in algebra and get it right, as long as you continue on to x is by itself. For me, if I were doing this, I probably would still do it literally this way, right? Some kids would say, yeah, it makes more sense. Let's divide everything by 2 right from the very start. Occasionally they'll do that, but forget that it's minus x and we divide by 2 though. Therefore, I'm going to divide everything by negative 2, and I get x is equal to negative 4. We good? What's 8 divided by 2? All right, good.
Wait.
What? Question? Nothing? We
I was
good?
so confused on that.
Are still confused?
I'm not.
Okay, good. Good? All right. And then the last one we'll look at is the ones with fractions. These are the ones that you claim are the hard ones. All right. What am I going to get rid of? The 2/3 or the 4?
4.
So how do you get rid of it?
Add 4 to both
All
sides.
right, well, let's add 4 to both sides.
2, 3, x.
Okay, let everybody else catch up. 6 plus 4 is 10. And the way I described it before is when you have a fraction attached to a variable and you're trying, that's it, that's your last step, and you're trying to get rid of the fraction, you multiply both sides by the thing that's attached to the variable flipped. Oh, by the way, that also works with 2x equals 10. You multiply by the thing attached to the variable flipped. So flip 2 and you get
1/2.
So technically, if I multiply both sides by a half, I get the answer. Cancel 10 divided by 2 is 5. It works that way for two. Nobody does it this way. But the same logic that will solve this one will solve all equations. Just nobody would do that. All right, so what are we going to multiply both sides by?
3/2.
3/2, right? Both sides. The 3's cancel, the 2's cancel. If you want to do some cross reduction here, this 2 would turn into 1, the 10 would turn into a 5 times 3 is 15, or multiply straight across. Either one. You would get 30/2, which is 15, or if you cross reduce, 5 times 3 is 15. There we go. Technically, this was part, remember, I said this is all just section 5.5. We're only halfway through right now. There's still another half to learn in this one section. Our book didn't do a really good job of this. You have 4 problems, box 9, and we'll call it a day. 4 problems in box 9. I'll give you the hint. Get rid of what first for the first one on the left? Then what are we going to do? Distributive property first. We're not distributing 2, distributing a -2. This one subtract 6 from both sides. This one subtract 5 from both sides. All right. Go ahead and do it. Yes, Jaden.
Wouldn't the -2, wouldn't the -2 and the +2 cancel out each other?
Not cancel because we're not doing division. We're doing multiplication. Yes. So put dot, and then 4 will be on the top. You put a row of 5. Both sides. And then, why did you write a 5? Again. Your hand is not listening to you. 4 divided by 4 is cancel. And then you're just left with x minus 2 equals. Stuck down here. X minus 2 is equal to. It's not a minus, that's a multiplication.
Oh, what?
You multiply both sides by 4. 24. Take it from there.
Wait, what?
Got it? Got it?
Turn around.
Which one? This is that special case one where we're trying to get rid of the. So you multiply both sides by the thing we're trying to get rid of. Multiply both sides by. Yeah, the 4's would cancel. Both sides. And then you're left with. And what's left on the left side? We'll solve that from there. Yeah, but same or different signs.
You've been so far today.
You've been so hard today.
Oh, yeah, that's actually what you're saying.
Right, so negative 2f.
Actually, in this heat,
So drop down to negative 2.
Over there.
you ain't going to do it.
By itself.
No, it's on.
Negative sign, your last step,
Good to
you
think.
multiply or divide.
And it's graceful to be careful. I believe you.
Perfect.
I believe you have a mental. I believe.
You wrote it perfect.
You're an eight. Yes, man.
Got it?
Yes, man.
Yeah. Count me up this stuff. Christian? First one wrong. What'd you do to both sides? First step. You did what? Well, how did you do it though? Yeah, so look what you do on the right side. You just told me you multiplied. Got this? Girls, got this? Yeah, but you didn't get rid of the x minus 2. So you were just multiplying both sides by 4. So you would be left with
I'm not doing it. Yes, you are.
just 4, not 4 over 4. 4 over 4 is.
Oh, no.
Yeah, but where's this 2 come from? Yeah, but we're only trying to get rid of the 4. Yeah. So the 4's cancel what you left with, that you would not cross out. You equals, let's get on the right side. Now solve that.
I know it's
Yeah.
Why did you do that?
Yeah, but I want to see all of your steps. And once you cancel,
Dude, minus 5.
okay, what are you left with?
Yeah. So you got that box small.
Yeah, you write that. You gotta write that.
I know the first 3 are right.
Yeah, but see how this is
I
written?
bet.
I read it under. So start right here. X minus 2. Because you notice you cancel the 4, so you cancel the X minus 2 equals what you left with on the right side. That's not what it says.
6 minus -8. -2. 1 after another 2.
Which is
You crazy, man.
equals 24. Now what? Well, what's attached to the variable? How do you get rid of it?
Which one are you on?
Both sides. What do you add to both sides? Yeah. Distributive property. 2 arrows. Use first arrow. What do you get when you multiply? Negative 2
Negative times
positive.
I'm gonna check your
Second arrow. Second arrow. You multiply negative 2 times, which is no,
and a negative times a
minus
positive
4
is a negative.
equals.
That's why it's minus 2
All you do is distribute, so equals.
opposite.
Right? What did he?
If it was negative, it would be negative.
Don't overthink it. Just write what it is.
It's you don't know A's. It's C. So you're saying it's C. It's not C. It's not C. Okay, so if I look, if this last answer is -2, think about it. -2 plus 8 is
It's all on.
So then we have
What do we get?
negative 2.
Six plus 4 is 2. Yeah, so it's not 2, it's. What does it say right
So
here?
now what we should do, it's
I
multiplication, I was thinking.
know, I know.
This
This is why you gotta.
So
So what's left on the left side? Yes, so negative 2f equals.
But a negative times a negative.
Yes. And I get rid of them 2.
It's not right.
All right, everybody look up here. Jenna, first one, final answer, x equals 20, 20. How did you get rid of the minus 2? You add 2 to both sides, so it's got 24. It's, okay. This one right here, if you made a mistake, it's because when you distributed, you didn't distribute a negative 2, you distributed a 2. So when you distribute the negative 2 to the inside, you get negative 2f minus 4 equals 6. Add 4 to both sides, you get 10. Divide both sides by negative 2, you get f equals -5. Ask questions, be brave. Yes. When you did the distributive property, read me what you got. Read me what you got. First line, quiet please. Well, that's what I'm saying. You got to use the distributive property first. Negative 2f minus 4 equals 6. Add 4 to both sides. 4 and 6 is 10. Divide both sides by negative 2, get -5. All right. This one, we should subtract 6 from both sides. If you made a mistake, I saw it in a couple people's paper. They had -2, -6, and they wrote something weird. 2 negatives, your same signs, you're adding. 2 plus 6 is 8, so you get -8. So we get negative t equals -8. Multiply or divide both sides by -1, we get t equals 8. Okay?
It was not. It was not.
Last one, we're subtracting 5 from both sides. Once again, subtracting 5, same signs. It means add, you get -21. So we get -3k equals -21. Divide both sides by -3.
10.3 repeating. No. I told him not to do that, but he did it anyways.
We get 7.
I got 13.
What?
21 divided by 3 is 7.
Oh, you did addition. Yeah, I subtracted 5.
Well, technically I did subtraction. Subtracted 5 from the
And
top.
then I got negative 3.
All right, time out a second so I can answer questions. Christian. Sure, the second one. The first arrow gives me negative 2f. The second arrow would give me minus 4. Questions on where I got those two numbers from? And that equals 10. Sorry, that equals 6. Second step, when we add 4 to both sides, get rid of minus 4, you add 4. We do, in fact, get negative 10. Negative 10. Positive 10. Boy. And then divide both sides by negative 2. Negative 5. Right. Yes. And you got minus 5. Same or different signs? That means add. 21. Negative 21. I know you did. That's why I said if you're going to make a mistake. Callie. I can't hear you. What did you say?
I was just wondering if you could.
Ah, thank you. All right. And your homework. Boy, it's a double shot today.
You're all taking homework right now.
Got the homework.
Yeah, we already got the homework.
How would you have your homework?
We already got our homework. Yeah. We already got it.
Oh, somebody reached on my desk.
Uh-huh. I did. I wonder who did it. Fine.
All right. Here's your homework. It is a, listen, please. Listen. It is a combination of regular ones and special case ones. Regular ones and special case ones. So, enjoy.
No homework.
If you make mistakes, which some of you will, right? Remember, mistakes come in 2 flavors. They come in the simple math mistakes. Negative times a negative is a positive, and you write negative. When you're, listen, please. When you're adding or subtracting with integers or positive and negative numbers, you can make silly mistakes. That's, I don't know, mistake type number 1, just a silly math mistake. Mistake number 2 is when you have procedure mistake, bigger one. Instead of getting rid of the 4, look up here, you add 2 to both sides. It's not a 2, it's negative 2/4. Procedure mistakes, lots of points taken off. A silly math mistake, you multiply both numbers on both sides by 4. For some reason, you write 22. I can see that you're multiplying. You just add a simple. That's a -1. Try add 2 to both sides. You don't know what you're doing for that one. Okay. All right. Test.
Yeah. No.
But you had one.
No, we didn't. Yeah.
You just said that you had
Oh,
one.
right.
Lying sacks of.
Yeah, I know what you're talking
Dang, now we have bigger.
I checked my pockets and I
about. My
couldn't
bad, guys.
see it.
All right, Christian. Brecton. Jaden. Pretty close to perfect, Jaden.
Darn it.
You got that A in mine.
Priscilla.
I gotta love
And I know something like
Abby.
the repeating decimal one. That's the one we did an example. and you
No
did it.
one got both bonus questions right. No one.
I didn't.
Jace didn't get a perfect score, but he got all the points.
Terminator.
Kai.
What? Hey, Martin, let's
Gemma.
go. Let's go. Let's go.
Pam.
You're freaking me
He's
out.
not here.
It was like a cheat.
Grace.
We were like,
He's
it was like,
Olivia.
I know, I heard it. It was like,
He got. Wait,
Amber.
I got bigger.
Good to see you.
I got better.
Aiden.
Wait a minute.
Prudence. Prudence. Oh, got the highest score, but she also missed. No, I lied. No, I didn't lie. You're not gonna be happy. She came as close to perfect. She got both bonus questions, but she missed something else. Gallup. Avery got more points than I offered, but she also did something. Amanda, David,
How was mine not bad?
Jackson,
You was one.
Glenn,
I got that though. I'm just on my portrait right there.
Gabby.
Yeah, I got 2 points.
What'd you get?
That's it. See you guys tomorrow.
I don't. I didn't shake on it.
All right, e-learners, that's it. See you guys tomorrow.